Hey everyone, and welcome to this explainer. So, get this. Did you know that Cambridge examiners consistently report data manipulation language, or DML for queries and maintenance, as one of the most profoundly misunderstood areas in the entire 9618 computer science syllabus? It's true. Global averages on these specific multi-step questions are shockingly low. It's just a massive point drainer for so many students. But hey, today, we're going to fix that. We are taking an exclusive insider's look into exactly what Cambridge examiners are hoping to see in your DML answers. We're going way beyond the basic code and looking directly at the assessment strategies that truly separate the top-tier candidates from everyone else. So get ready to take some mental notes because this is a real game changer.
All right, here's our roadmap for today. We'll start by tackling the DML assessment challenge. Then we'll build up your theoretical architecture, break down the method mark strategy, and navigate through the top examiner traps. Finally, we'll wrap things up with evaluative thinking.
Okay, let's jump right into Section 1, the DML Assessment Challenge.
So, it's time for a pretty hard truth. You might leave the exam hall feeling totally confident, only to realize later that you completely missed the mark on these specific questions. Why is there such a massive disconnect between studying the material and actually scoring the points? Well, to answer that, we have to look directly at the principal examiner reports, which pose a really crucial question. Why do students find multi-step calculations and method marks so remarkably hard? The reality is, a lot of people treat DML like it's just a simple memory test. They memorize isolated commands, right? But then they freeze up when a question asks them to actually extract data from binary representations, perform a complex calculation, or draw an evidence-based conclusion. The problem isn't that you lack knowledge, it's a lack of strategy for multi-step execution. And that is exactly the core issue we're solving today.
Moving right along to Section 2, building theoretical architecture.
To beat the challenge we were just talking about, you absolutely cannot rely on rote memorization. You need what we call theoretical architecture. Now, this isn't just knowing what a command does. It's the foundation of precise definitions, understanding causal relationships, and critically, integration with other syllabus areas. Actually, I need to issue a massive examiner alert right here. The reports reveal that candidates consistently confuse key terminology. And look, if your definitions aren't sharp, your entire answer just crumbles. Always, always define your terms clearly and precisely before you even start writing extended responses or using them in your analysis.
And the payoff for building that solid architecture is huge. Straight from the source. Candidates referencing cross-topic connections achieve significantly higher marks. You see, the Cambridge syllabus actively emphasizes that top-performing students show a connected conceptual understanding. This means your knowledge has to be transferable to totally unfamiliar contexts. Think about it. If you can show the examiner how a DML maintenance query impacts data structures or algorithmic efficiency from an entirely different part of the syllabus, you are signaling true mastery. You're not just repeating facts.
Which brings us to Section 3, the method mark strategy.
Now, this is where we actually turn all that theory into solid exam points. You see, the assessment objectives target distinct cognitive domains: knowledge, application, and analysis. And examiners, they don't just want the final answer. They want to see your brain working. When you're tackling any DML question, follow this exact procedural framework. First up, deconstruct the question so you understand the exact context. Second, extract the relevant data you actually need to work with. Third, select the right analytical framework for the problem. And fourth, execute your solution with crystal clear notation using the correct terminology. If you just skipped these steps and jumped straight to a final line of code, you are leaving guaranteed method marks right on the table.
Basically, tackling DML is essentially an exercise in algorithmic thinking and data interpretation. It requires step-by-step decomposition, picking the right data structures, efficient code implementation, and showing how you'd rigorously test it. Plus, your data interpretation skills are absolutely critical here. You've got to be able to extract from binary, perform calculations, and draw really strong evidence-based conclusions. If you map your answers out to this framework, the examiner can literally follow your logic step by step and award you marks all the way down the page.
All right, let's head into Section 4, top examiner traps revealed. Look, even with a flawless framework, the exam hall is just full of hidden dangers. The principal examiner reports have very generously highlighted 3 massive red flags that consistently cost students valuable grades. First is a classic trap, using the wrong formula or algorithm for the specific context provided. Second, and please pay special attention to this one, is forgetting to check boundary conditions and edge cases. Examiners are actively looking for students who test the absolute limits of their DML maintenance queries. And third,
writing generic, textbook answers that aren't specific to the context given in the question. Honestly, if your answer could apply to literally any database, it's not going to get full marks for the specific scenario you were handed.
So, how do you avoid panicking and falling into these traps? Well, here's a highly recommended memory hack. Try using a visual story method to encode these complex DML concepts. Instead of just memorizing dry syntax, visualize the data physically moving through the multi-step process. Create a little mental narrative of extracting the data, selecting the framework, testing those edge cases, and finalizing the query. This visual story acts as a reliable mental checklist during the pressure of the exam, making sure you never skip those vital boundary checks. Finally, we're at Section 5, Evaluative Thinking for Top Marks. So, how does all of this build up to the absolute pinnacle of the grading rubric? We are now dealing with the highest cognitive domains out there, application and critical analysis. If you want to know what truly separates the A grades from the rest, it boils down to evaluative thinking. Average candidates will just list isolated facts, write down some code, and move on. Top candidates, though, they perform true comparative analysis. They detail both similarities and differences. They deliberately use comparative connectives to link their ideas together. They support every single comparison with hard evidence from the scenario, and they draw meaningful conclusions about relative importance. They don't just say what a piece of DML does, they explain exactly why it is the superior choice for that specific database maintenance task. Think of evaluative thinking as your personal checklist for impressing the examiner. It demands that you consider multiple solutions or alternative approaches. You've got to analyze the trade-offs of using one DML method over another. It also means you must be brave enough to acknowledge the limitations of your own proposed solution. And lastly, you have to clearly justify your decisions with solid evidence. It's this exact depth of critical analysis and justified recommendation that locks in the highest possible marks. To wrap things up, I want to leave you with a bit of a provocative thought to challenge your current study habits. Take a look back at your recent past papers and ask yourself, are your DML answers just reciting memorized code, or are they evaluating trade-offs, building theoretical architecture, and proving true mastery? Applying this exact examiner's playbook is what transforms a good student into a top-tier candidate. Thank you so much for joining me for this explainer. Keep practicing those method marks, and I will see you next time.